I'm Alejandro. I'm the econometrician,
I'm Arvin and I'm the writer.
And I'm Salome, the theorist.
and our research question is, does circular economy practices actually improve the profitability?
So, what was our motivation for this? Climate change and resource depletion are pushing economies to rethink the traditional take, make, dispose model, which creates a lot of waste and relies heavily on virgin materials. The circular economy offers an alternative by keeping materials in circulation longer through reuse, recycling, and remanufacturing. Sweden has become a leader in this shift because of strong policies and a culture that supports environmental innovation. Understanding why this matters helps us set up the question of whether these sustainable practices also make economic sense for firms. With that motivation in mind, we started by asking a simple but important question. Our study focuses on whether adopting circular economy practices actually improves profitability for large Swedish manufacturing firms. Manufacturing is the right sector to analyze because it relies heavily on materials, so circular practices could directly affect cost and efficiency. And since Sweden already has national and European level policies supporting circular transition, it provides a strong environment to test this relationship. Ultimately, we want to know whether sustainability-driven changes can translate into measurable financial gains. To explore that question, we looked at what existing research tells us. Prior research gives several reasons circular practices might affect profitability. The Porter hypothesis suggests that environmental regulations can push firms to innovate, improving competitiveness. And then another economist points out that waste itself is a sign of inefficiency, meaning firms may benefit from reducing it. Studies in Sweden show growing adoption of circular methods, although the level of implementation differs widely. So overall, research hints at possible financial advantages, but the results are mixed enough that we need data to really test the relationship.
In this section, I'll walk through the economic theory behind circular production systems and how they can and sometimes cannot influence firm profitability. My goal is to show not only the potential benefits, but also the economic frictions that make profitability far from guaranteed. Let me begin with the concept itself. A circular economy is essentially the opposite of the traditional take, make, disposal model. Instead of extracting raw materials, producing goods, and throwing them away, the circular model aims to keep materials in use for as long as possible. It does this in three main ways: narrowing resource flows, meaning firms use fewer materials in the first place; showing resource flows by extending product life through repair, refurbishment, and remanufacturing; and closing loops through recycling and recovering materials. Researchers describe these strategies as R frameworks: reuse, repair, refurbish, remanufacture, and recycle, applied at the product level, firm level, and even regional or national economic systems. Circularity overlaps with sustainability, but isn't exactly the same. It focuses more specifically on materials, product design, and resource productivity. Policies such as the EU Circular Economy Action Plan and Sweden's national strategy give direction to firms, but they do not promise profitability outcomes. The economic effects are still an open question. Next, there are two big theoretical foundations here. First, environmental economics and the classic materials balance principle. What we just heard from Arvind tells us that input eventually becomes either a product or a waste stream. If a firm can reduce waste by reusing or recovering materials, it lowers the total amount of virgin inputs it needs. So, circular practices can reduce material throughput, and this can shift the firm's cost curve downward. Second, from the industrial organization perspective, Michael Porter famously argued that pollution is actually a sign of inefficiency. Firms are paying for inputs they fail to use. Well-designed environmental policies can therefore trigger innovations that improve efficiency and potential competitiveness. This is known as the weak Porter hypothesis. But the strong Porter hypothesis that environmental innovation always raises profitability has much weaker empirical support. Let's move on the microeconomic mechanisms. These are the channels through which circular adoption could actually affect firm performance. On the cost side, circular practices reduce waste and increase material reuse. If secondary materials become cost competitive, after accounting for things like collection, sorting, and quality control, then the firm's marginal and average costs fall. Circular operations often require redesigning processes, and as workers repeat these new tasks, learning by doing can improve yields and reduce scrap, lowering costs further. But there's a catch. Circularity also increases coordination needs. Reverse logistics, quality testing of returns, and tracking material provenances all create transaction costs. If these exceed material savings, profitability gains disappear. On the demand side, circular attributes like durability, repairability, or guaranteed take-back can differentiate a firm's product. In a monopolistic competition setting, that lowers price sensitivity and can support higher markups, but only if consumers trust and value these attributes. And that varies widely across markets. Circular adoption also reshapes capabilities. Early movers develop routines in eco-design, return flow management, and quality assurance. These capabilities are difficult for competitors to copy and can act as entry barriers, supporting quasi-runs. Another channel is risk management. By securing reliable secondary material streams, firms hedge against volatile commodity markets. Even if average costs don't fall, the reduction in cost uncertainty can improve investment decisions. Despite all these potential advantages, the economics make it clear that profitability gains are not automatic, and in many cases may not appear at all. Transitioning to circular systems requires substantial upfront investment. Secondary materials are not free. They involve collection, sorting, cleaning, testing, reverse logistics, and sometimes lower quality or higher variability. Firms must redesign products for disassembly and train staff. These costs hit operating profits long before learning effects kick in. Even when circular practices reduce costs, markets often compete those savings away. Pass-through pressure means firms may lower prices rather than keep the extra margin. Demand-side benefits also depend on trust. If consumers are uncertain about refurbished quality, willingness to pay collapses. And as more firms adopt circular models, the early mover advantage shrinks. Policy-driven innovation is real, but it is costly, and commercialization can lead behind R&D. Plus, circular models introduce new risks: cannibalization of new product sales, working capital burdens in product as a service models, producer responsibility costs, and the need for high return volumes to reach scale efficiency. Put together, these frictions can offset the theoretical gains. This brings us to our hypothesis. Because circular adoption creates both cost savings and new costs, and because demand, competition, and firm capabilities vary so widely, we take a neutral stance. Our hypothesis is that adopting circular practice does not systematically change profitability among largest Swedish manufacturing firms. The supporting model illustrates this. If circular adoption neither meaningfully shifts the cost curve nor the revenue curve once transition costs are considered, then the profit maximizing quantity, the peak profit, and the break-even points remain exactly the same. And the two curves, adopters and non-adopters, coincide. This visual shows what our theory suggests. The gains and the losses may simply cancel out. Now, how do we operationalize circular adoption? We use the Eurobarometer survey, which asks firms what circular actions they have actually undertaken in the past 2 years. These include recycling, reuse, energy savings, designing products for repair, and so on. To distinguish true adopters from firms doing only minimal circular activities, we treat firms that report 3 or more actions as adopters. This measure aligns well with the theory because it captures behavior, not certification. And because Eurobarometer is fully anonymous, firms have no incentive to exaggerate or underreport to influence procurement or ESG evaluations. When interpreting these results, it's important to consider several external factors that can shape the profitability patterns we observe. First, the Eurobarometer actually counts as a noisy proxy. They tell us what firms say they do, not the operational depth behind those actions. Resource efficiency gains also differ across manufacturing sectors. In some cases, virgin inputs remain cheaper than recycled or recovered alternatives. Because the data are anonymous, we also cannot link firms to audited accounts or verify performance. A further complication is the difference between accounting and economic profit. Accounting profit subtracts only explicit costs, while economic profit deducts opportunity costs as well. This means a firm may appear profitable on paper, yet still generate zero or negative economic profit. So circular actions may look profitable in surveys without actually improving true economic performance. At the same time, Swedish environmental norms and regulatory expectations, including the Environmental Liability Directive, extended producer responsibility, the CSRD reporting requirements, and rising ESG scrutiny, all shape how firms behave and report sustainability efforts. Large firms with market power may also adopt visible circular practices to avoid regulatory pressure or public criticism, a form of strategic obscurity that looks like circular commitment even when it is not driven by efficiency. However, because Eurobarometer responses are fully anonymous, these strategic motives affect real behavior, but not how firms answer the survey.
All right, let's get into our data source. Let's go briefly over the data source. For this study, we use firm-level study data from the Flash Eurobarometer 498 collected during the 2021 to 2022 and provided by the European Commission through ACES. We focus specifically on Swedish manufacturing firms to ensure a consistent regulatory and policy environment to keep the firms comparable in terms of scale and financial capacity. We restricted the sample to large firms with 250 or more employees. Because the survey captures circular practices and profitability at a single point in time, our analysis is cross-sectional. This data set allows us to examine how circular economy adoption is associated with profitability across all firms. Our analysis centers on two key variables. The first is profitability, labeled GU, which is a binary variable. A value of 1 means the firm is being reported as profitable within the past 2 years, and 0 means it broke even or operated at a loss. This tells us whether a firm is profitable, not how much profit it earned. The second variable is circular adoption, labeled GT. This is also a binary variable. Firms were coded as adopters if they reported 3 or more circular economy actions, such as recycling, reuse, or products redesign. Firms with fewer than 3 actions were classified as non-adopters. Using these binary variables allows us to make clear comparisons between adopters and non-adopters. For running any test, we first looked at some basic descriptive statistics. We found that only 32% of firms reported being profitable, which reflects on how competitive and cost-intensive the manufacturing sector really is. At the same time, about 41% of adopted 3 or more circular practices, indicating a moderate level of circular adoption across the sample. We also observed that most firms were both non-profitable and non-adopters, and there was a substantial variation in both profitability and circular activity. These patterns give us a good foundation for comparing adopters and non-adopters more formally. Our empirical strategy is straightforward. First, we divided firms into two groups, adopters, which served as treatment groups, and our non-adopters, which are served as a control group. Next, we used two sample t-tests to compare the average profitability between these two groups. Finally, we estimated a linear regression model to quantify the relationship between circular adoption and profitability of being profitable, while confirming the magnitude and statistical significance of the effect. Let's go to our two sample t-tests now. The two-sample t-test compares the mean profitability of adopters and non-adopters. We found adopters reported a profitability rate of about 48.6%, while non-adopters reported only 18.3%. This gives us a difference of 30 percentage points, which is statistically significant at a p-value of less than 0.001. In practical terms, this means that firms adopting circular economy practices are nearly 3 times more likely to be profitable than firms that do not adopt them. To further examine this relationship, we estimate a simple linear regression. We're not trying to make this complicated or anything. The adoption coefficient is 0.303, meaning the adoption increases the probability of being profitable by about 30 percentage points, which closely matches our t results. The p-value remains below 0.001, confirming strong statistical significance once again. The model of the R squared is 0.066, which indicates modest explanatory power. This is expected because probability is a binary variable. It depends on how many other factors beyond circular adoption. The graph visually summarizes the regression results. The fitted regression line shows a clear upward trend indicating a positive relation between circular adoption and profitability. Firms that report circular adoption consistently exhibit higher predicted profitability values than non-adopters. The visible separation between adopters and non-adopters reinforces the statistical significance of our findings and makes the relationship easy to interpret. Overall, the graph helps communicate our empirical results in a clear and intuitive way.
Our results show that in Sweden, firms adopting circular practices are more likely to be profitable. The policy environment plays a big role. Strong national support and higher consumer interest in sustainability both make circular strategies more rewarding. This outcome supports the idea that environmental innovation can improve competitiveness. And it goes against our initial neutral hypothesis since adopters actually performed better financially. However, these results are shaped by Sweden's unique policy environment, which isn't the case everywhere. In the United States, circular adoption looks very different. There's no national circular economy framework, so efforts vary widely across states and companies. The lack of consistency means American firms face weaker incentives to adopt circular practices than firms in Europe. Because of this, it becomes difficult to compare U.S. firms directly with Swedish ones or expect the same profitability outcomes. Like any study, our findings also come with limitations. Our data is based on self-reported survey responses, which can introduce bias. Profitability is measured in a simple yes or no format, so we can't see how profitable firms actually were. The data set is cross-sectional, meaning we can't prove that circular adoption causes profitability, only that they're linked. And because we only know firms are large, not their exact size, we can't fully control for differences within that category. These limitations don't undermine the results, but they do add important context. Even with those limitations, some clear conclusions emerge. We found that circular adopters were about 30% more likely to report profitability than non-adopters, but the t-test and regression consistently show a strong positive relationship between circular adoption and profit status and suggest that sustainability and profitability can work together. Sweden's strong policy support likely helped firms capture these benefits. Finally, this opens the door for future research. Future research should use audited financial data to measure profitability more precisely and track firms over time to understand long-term effects. Expanding the study to more European countries could help compare different policy environments. As circular economy metrics develop in the US, similar analysis could eventually be done there. It would also be useful to identify which specific circular practices produce the strongest financial impact. In summary, Sweden demonstrates that circular economy practices can deliver real financial value, not just environmental benefits. There's still more to learn, but the evidence is clear and promising. Thank you for listening to our presentation.